Okay, so today, right now, we're going to talk about this physics and the scientific method. Um, just come up with some terms and some ideas to describe how they work together. Um, Obviously, physics, as you may or may not study, the fundamental laws of nature. In fact, everything in nature obeys the laws of physics. And this is from the smallest things to the largest things. And the goal of physics is just to gain deeper understanding of those things, how the small things and the big things work together. And we prove it mathematically by using physics. It's one of many natural sciences. Obviously, chemistry, biology are other courses that you've probably taken before this, and in geology, and there's many others. So science is a way of looking about how nature and things work, and so you're trying to understand why and the how. Science is a process, um, and it's not just a thing that happens, and it's not just a collection of facts. It's a whole method, if you will, the scientific method, as you've studied before. Scientists attempt to gain and find explanations for knowledge that has been gained from natural events. So there's a systematic approach to doing this, and that's the scientific method. And there's a lot of different things that you've probably learned about the scientific method, but the steps are essentially this. One, you observe. So you come up with something that you see, and you try to infer and hypothesize why that happens. And then you find a way to test to see if your observation can happen again based on your inferences and what you hypothesize. And then after your test, you draw a conclusion. And that conclusion could lead you back to make more observations. It very rarely the first time gives you an actual conclusion that tells you why the observation happened, but it gives you ideas as to how you can go and make your next test, and probably take your hypothesis and modify it and try to test it again to see if that makes the difference or not. But these are the main four steps in the scientific method. So the first step, careful observation. It's important to be creative in observations, and so you have to be very careful and look at things and try to see things as no one else has before. Now, these observations do lead to inference and hypothesis. Now, the difference between an inference and a hypothesis: an inference is a logical interpretation of your observations. A hypothesis, all right, is more detailed. It's a scientific explanation for your observations, and then that's what you're testing. So an inference is an interpretation of what you observe, but a hypothesis is actually an explanation, and that's where you try to make a test to either verify or reject your hypothesis. Usually hypotheses make predictions that can be tested with experiments. So now if your experiment verifies the prediction, then your hypothesis gains support. If it disagrees, you must either reject or modify it. A lot of things in science have started with a hypothesis that seems to go against what other people thought, right? One guy we're going to talk about down the road is Galileo. And when Galileo said heavy objects fall at the same rate as light objects, obviously that could not be seen by the naked eye, and it didn't appear to be that way. However, he knew that from other things that he saw, and also the experiments that he ran, he could prove this, and he was right. So a scientific theory then is a detailed explanation of some aspect of nature that accounts for a set of hypotheses. So usually a test is ran and the hypotheses are tested a bunch of times. After they're tested a bunch of times, a theory is then developed. Now, theories are well-supported explanations. An example of theories out of gravity. And we have seen gravity fall a lot of different times, and we know gravity is at a constant acceleration on the Earth's surface because we've seen it and applied it a bunch of times. On the other hand, laws of nature are well-supported descriptions of nature, like the law of conservation of energy. And laws and theories, the difference between them is asked a lot. Usually laws you can see happen all the time, and then gravity is just an explanation, and usually a theory itself hasn't been supported enough to be considered a law, but some would say that gravity could be a law. But laws don't provide explanations. They just tell you what they see, okay? And then what happens with a theory then, if new observations disagree, the theory has to be revised. When this happens, it's usually means there's something happening in science that's going to change things, right? So if a theory is tested and then proven wrong, then that's when we start to see science really start to work.